Hello everyone. So welcome to today's session. Now in this session, let us discuss about the third abiotic factor, which is light. So in lecture number 4, we discussed about the first abiotic factor, which is temperature. In lecture number 5, we discussed about the second abiotic factor, that is water. Now in lecture number 6, let us discuss about the third abiotic factor, which is light. Okay, let's go with the third abiotic factor, which is light. Okay, now sunlight is a main source. Sun is a main source of light also, temperature also, isn't it? So sun is the major source for light as well as temperature also. Sun is a major source for light also. It is a major source for temperature also. Now, how much percent of the sunlight will come and hit the ground is the photosynthetic radiation, PAR we tell, photosynthetic active radiation. 50% of the sunlight comes and falls on the ground, which is photosynthetic active radiation. We tell like less than 50%, okay, of sunlight, you know, less than 50% of the sunlight is PAR. Now what is PAR? Photosynthetic active radiation. Photosynthetic active radiation. So less than 50% is PAR then, which is coming and hitting the ground. Now 50% is coming on to the ground, but is that 50% used by the plants? No, again. Only 2 to 10% of the PAR is used by the plants. Okay. So that means 2 to 10% of PAR is used by the plants for doing photosynthesis. Now, in 50%, if they are using 2 to 10%, 100% sunlight what it is there. Now in 100%, 2 will become 1, 10 will become 5. That means out of total sunlight, only 1 to 5. 2 becomes 1, 10 becomes 5. Because 50% it is 2 to 10 means 100% it will be 1 to 5 only. Out of the total sunlight, only 1 to 5% is used by the plant. Is used by the plant to do photosynthesis. Or we can tell that it's minimum 1%. We can tell only 1% of the sunlight is used by plants for photosynthesis. Now again, if we see the photon energy, sunlight energy, now what are the radiations we can find? The radiation scale, if you see. So UV rays are there, visible rays are there, IR radiation, infrared radiation is also there. UV is divided into UVC, UVB and UVA, and visible light is divided into violet, vibgyorite, indigo, blue, green, yellow, VIB, GYO and R. This is the visible range. So this is a visible range. Then what is the infrared radiation? Here on, it is infrared radiation. So even radar waves are also there. Radar waves, radio waves are also there. We are not concerned with that. So I am just showing above visible range is UV radiation. After visible range, it is infrared radiation, right? So now in this UV, if you see, like UV radiations are from which wavelength to which wavelength, visible radiations are from which wavelength to which wavelength. We know that the visible radiations are from 390 nanometers to 760 nanometers. Beyond 760 is then IR, yes. Now, less than 390 will be UV. Less than 390 will be UV. Then UVA how much, UVB how much, and UVC how much means UVA will be from 100 to 280 nanometers. UVA will be from 100 to 280 nanometers. UVB will be from 280 to 320 nanometers. And UVA will be 320 to 390 nanometers. So, the UV radiation is from 100 to 390 nanometers. 100 to 280 is UVC. 280 to 320 is UVB. 320 to 390 is UVA. Now, among this, UVC is very lethal, okay? Dangerous. UVB is, we can tell, it is moderately dangerous. It is moderate, we can tell it's moderately harmful. And if we come to UVA, so we can tell it is little harmful. Harmful only, but. Now, in this violet to red also, which is ranging from 390 to 760, how much is PAR? Completely from violet to red, it is not PAR, no? The PAR is from 400 to 700. So, if we have to tell PAR, the PAR, photosynthetic active radiation, it ranges from 400 to 700, which is photosynthetic active radiation, which can be taken by the plants to convert carbon dioxide into water to carbohydrate, which is nothing but photosynthesis. It's nothing but photosynthesis. Okay. Now, we know that in the upper layers in the atmosphere, so there's an ozone layer. Ozone layer acts as a filter to trap the UV radiations. UV radiations are harmful. They cause mutations. So, when the ozone layer is undamaged, 100% of this lethal UVC will be absorbed and 50% of the UVB will be absorbed. Ozone absorbs 100% of UVC and 50% of UVB it absorbs. So, most of the harmful radiations ozone will absorb. But because of the pollutants, the ozone layer is getting damaged. That's why UV radiations are coming down, which is causing skin cancers and all those things, right? Now, light, for what reasons it is required? So, we will see. So, light influences many activities like photosynthesis, growth also, pigmentation also, foraging activity, right? So, all these things are influenced by the light. Let us write down one by one and discuss on those topics, right? So, light influences activities like first one, photosynthesis. We know that the plants have pigments. Pigments are present inside the chloroplast. Pigments will absorb sunlight. That sunlight, which is a photon energy, is converted to chemical energy. That chemical energy is used by the carbon dioxide to get reduced to carbohydrate. Means for photosynthesis, to reduce carbon dioxide into carbohydrate, light is required. Okay. The second one, for growth also. Now, growth is an anabolic process. Anabolic process requires energy. Now, energy, it comes from when we eat the food, we get energy. Now, who are preparing the food? Producers. How will producers prepare the food? By taking the sunlight. So for growth also, light is required. For growth also, light is required. Then for pigmentation. Now, organisms which are in polar regions where sunlight is less, they will be less pigmented, they will be pale. Where the organisms which are at higher levels, at the equator levels, they will be more pigmented. So pigmentation is also influenced by light. Movement is also influenced by light. Is also influenced by light. The animals which are active in the presence of light are called diurnals. Diurnals means they are active in daytime. And if you go the other way, nocturnals, they are active at night. Right? So, means for movement also light is required. And for foraging of the birds and animals also light is required. So, foraging means for food, for reproduction, and for migratory activities also light is required. For foraging activity means for collecting the food. For collecting the food, they require light. For reproduction, they require light. And for migrating, they require light. Right? And for photoperiodism, also light is required. For what is photoperiodism? Photoperiodism is a minimum amount of the light which is required for a plant to flower. It helps in flowering. Now, depending on what is that light, how much amount of light is required for the plants to flower, we can categorize the plants into short day plants, long day plants, day neutral plants. We can categorize the plants into short day plant, then day neutral plant, then long day plant. Now, short day plants, they flower. When do they flower? So, when the light below the critical length also, if they are flowering, then they are short day plants. Short day plants flower below the critical length, length of light, critical light. Long day plants require light more than the critical length to flower. They require more than critical length to flower. Day neutral plants, critical length is not affected. So throughout the year they flower. Throughout the year they flower, right? So what did we discuss so far under light? We discussed what are the sun is a source for temperature also, light also. And we discussed like what is the range of light, what is photosynthetic range of light, and what is above that UV. UV is good or bad? It is bad. So UVC is very bad, it is lethal. UVB is moderately lethal, and UVA it is little lethal. If ozone layer is there, then UVs are absorbed, right? And then we discussed the light influences many activities like photosynthesis, growth, pigmentation, movement, foraging, photoperiodism. On this basis, we are categorizing the plants into short day plants, long day plants, day neutral plants. Now, deep inside the oceans, they don't even know that celestial source called sun is there which provides the light. Okay. So, in the deep water ocean bodies, they don't even know that a sun, a celestial source of energy is there. Organisms are not aware of sun as a celestial source of light and energy. Then how do they get their energy which are bottom at the benthic level? Means bacteria, they do chemosynthesis and they give the energy. So these organisms obtain energy because sunlight cannot penetrate deep inside. They don't even know how do they get their energy. By chemosynthetic bacteria. They break the chemicals and they give that energy. Using that energy, so these organisms, benthic organisms, will survive. Then next one, all the ranges of light cannot penetrate deep into the ocean. Nephritic algae, which are completely aquatic forms. All the forms of algae are not available at every place. Now, on the upper surface, you know, green algal forms will be there. And at the middle level, brown algae will be there. Bottom level, you know, this is up, middle, the bottom level. At the bottom level, red algae will be there. So, green algae requires abundant sunlight, that's why they are on the top. Now, blue light, you know, blue light is of short wavelength. Blue light is of short wavelength, and the wavelength is short, penetration power is more, and can penetrate deep into the ocean. So red algae, then they can trap this blue light. Okay, so red algae trap blue light to do photosynthesis. So red algae, they are trapping blue light to do photosynthesis. Now we can, depending on the light, we can divide the zones into two types. What are the zones we can divide? Means we can divide them into littoral zone and lemnetic zone. What is this zone? And what is this zone? So, littoral zone means it's a shallow water body. Means it's at the edges. So, littoral zone is a shallow water zone present at the edges. It is a shallow water zone present at the edges of water bodies. Now, what is lemnetic zone? It is an open water body zone. Again, in lemnetic we have three zones. Where 100% light can penetrate is called photic zone. Little bit only light will penetrate, profundal zone. Light penetration is very less, negligible, benthic zone. So where 100% light can penetrate, what is it called? Photic zone. Little only light is penetrating, profundal zone. Light penetration is very less. It's called benthic zone. So we discussed in this class about the next abiotic factor, that is light. So we have seen how light is important and what are the factors which influence the light. So in the next session, we will discuss about the last abiotic factor, which is soil. If you like the content, please like, share and subscribe to my channel. Thank you.